In this video, we are going to learn about error handling in Python, which will guide you to understand and manage exceptions to make your code more reliable and robust. Without wasting time, let's dive into the video. Let's start with the basics by understanding what is an error. In Python, errors are also known as exceptions, which can interrupt or stop the execution of a program. By using error handling, we can improve code robustness, meaning we give the code ability to handle errors and makes debugging easier and code reliable. To overcome these errors, Python provides a systemic way to handle these errors by using try and except blocks. With that understanding, let's look at various types of errors you may commonly encounter in Python and how can it impact our program. Python has several error types. In those, syntax error, type error, value error, and zero division error are the most common error types we encounter during an execution. Syntax error occurs when Python syntax is incorrect. In the following example, as you can see, there is a missing colon at the end of the syntax. As the syntax is wrong for this if block, if you try to execute this, then syntax error will arise. Like this, whenever a code violates the rule of Python language syntax, syntax error will arise. Some common causes of syntax error include missing or misspelled reserved keywords, spaces, quotes placed improperly, indentations and incorrect usage of blocks, invalid declarations, etc. Next, type error. A type error happens when we perform operations on incorrect data types. For example, we are performing addition in between an integer and string, which are incompatible data types to perform this addition. Like this, errors in Python comes in many forms, each with its having many examples. While I will cover the most common types and provide a clear example for each error in this video, there is a whole world of additional scenarios and examples out there. If you are curious to learn more examples on each error, I recommend you to browse through the net, which can offer a lot of information. Coming to the video, next up, value error. A value error occurs when a function receives an argument of the right type but an inappropriate value. From this definition, you may be little confused, but if you carefully understand the example which I am going to tell now, you can easily learn this topic. In the example, the int function is called with the argument abc. This int function is a built-in Python function that converts a given value to an integer. Here, the argument which we provided is of integer type. The int function can only convert the string to integers only if the string represents a valid integer. Means if the strings would be like 1, 2, 3 in double quotes or any number in double quotes is considered as string. Those strings can be converted into integers, but these ABC or any form of alphabets in double quotes cannot be converted into integers. So ABC cannot be converted into an integer. Python raises a value error. Moving to zero division error. Zero division error. From the name itself we can tell it is raised when we divide it by 0. As you can see in this example also, we are dividing 7 by 0. So when we run this program, we get zero division error. Now that we have seen some common error types, let's explore a few more specific ones, especially those related to mathematical and index based operations. Index error, which is raised when we try to access an invalid index which is not present in a list or tuple. For example, if you consider this list, it has index from 0 to 2. In the next line, we are trying to access the index of 5 which is not at all present in the list. So in these cases, as we are trying to access an invalid index which is not present in the list, index error is raised. Moving to arithmetic errors. It can occur when the arithmetic calculations fail, and it is the base class for those built-in exceptions that are raised for various arithmetic errors like overflow error, zero division error, and floating point error. Coming to the example, if we try to find the square root of -1, Python program will raise an error to a negative number which is not defined within the domain of real number. Square root can be done only when the number fall into the domain of real numbers only. Instead, this -1 belongs to the domain of complex numbers. So Python raises arithmetic error. It may be little bit confusing to understand, but in simple words you can tell arithmetic error exceptions arise when a mathematical operation fails due to invalid input, which is -1 here, or operations. In those cases, arithmetic error exceptions arise. An overflow error is raised when a calculation exceeds the maximum allowable value, or when the input size exceeds the initialized size of the variable. In these cases, this error will occur. Coming to this example explanation, the exponential function is used to calculate the exponential of the given argument. In this case, that is, when you try to find the exponential for this, the result will be large and exceeds the maximum value that a float can represent in Python. Since the result for this is very large, Python raises an overflow error. Next up, floating point error. Floating point error occurs when the calculation of floating point value fails due to limitations of binary representation and precision. Generally, floating point numbers are stored in a binary format. Some decimal numbers like 0.1 and 0.2 cannot be represented exactly in binary. Instead, they are stored as approximations. Coming to this example, when you try to perform addition in between 0.1 and 0.2, the result will not be exactly 0.3 due to these precision errors. The actual result of 0.1 plus 0.2 in binary is slightly more than 0.3. So this comparison results false. In addition to arithmetic and index errors, Python also has other error types that often arise during importing, file handling, and working with dictionaries. Let's go over those next. Import error occurs when Python cannot find the module you are trying to import. This usually happens if the module is not installed or the given file name is wrong or mismatched. In the following example, we are trying to import a module named non-existent module. Python looks for this module in its list of installed packages. Since non-existent module does not exist, Python cannot find it. So it raises an import error. Key error. Key error occurs when you try to access a dictionary key that does not exist or mismatched in the dictionary. In this example, simple dict is a dictionary which has only one key, that is name. In the next line, we are attempting to access the key age which does not exist in this dictionary, leading to a rise in key error. Next, name error. Name error occurs when you try to use a variable or function that has not been defined or not found. Here, variable is not defined before it is used, leading to name error. Lastly, file not found error. A file not found error occurs when you try to open a file that does not exist. In the example, I am attempting to read a file named non-existent file which does not exist, so it raises a file not found error. By understanding and handling these common Python exceptions, you can make your programs more reliable and user-friendly. Now that we have covered the types of errors, let's discuss how we can handle them in Python using Basic try and except blocks. Using the try and except block allows you to handle exceptions gracefully, providing alternative actions instead of crashing your program, so that you can ensure your programs run smoothly even when an error arises. The basic syntax of try and except is try followed by colon. In the next line, indent the code. After that, write the code that might raise an exception. Next, except followed by exception type and colon. In the next line, indent the code and write the code to handle this exception. You should always know that try block contains the code that might raise an exception. In this case, dividing 10 by 0 raises a 0 division error, and the except block catches the 0 division error and execute the code to handle it by printing an error message that is cannot divide by 0. If you run this program also, you will get the output cannot divide by 0. Instead of crashing the program, the try except block caught the error and handled it. While a single except block works well for one type of error, in many cases we need to handle multiple specific errors. Python allows us to do this with multiple except blocks. Here is how. You can handle different types of exceptions using multiple except blocks. This example handles two types of exceptions: value error, which occurs when a function receives an argument of the correct type but an inappropriate value, and the next exception is type error, which occurs when we perform operations on incompatible data types. When we execute this code, we get output as value error occurred, as we have provided string to be converted into int, which is not possible, so value error occurred. Instead of Python, in string, if we had any numeric values, we can convert that number to int. As we cannot convert any alphabet into numeric, so we get this value error. In some cases, we may want to take action only if there is no error in our try block. This is where the else clause becomes useful. Let's see how it works. The else clause is executed if no exceptions are raised in the try block. Coming to this example, in the try block, we are performing division and assigning it to the result. As this division will not raise any exception, this else clause get executed and displays the result, that is 5. Instead of 2, if it has 0, this except block will get executed and will print the result cannot divide by 0. In the try block, as the exception is occurred, this else block will not get executed. I hope this clears your doubt. When will this else clause will get executed and when will it does not get executed. Finally, there are some situations where we need certain actions to happen no matter what, whether an error occurs or not. For that, we use the finally block. The finally block is executed after the try and except block. Regardless of whether an exception was raised or not, this final block will get executed. If we execute this code, we get the result value error occurred, and also this finally block will get executed printing this is finally block, it always runs. The finally block can be used with or without this except block. If no exceptions are expected to be caught, you can use try and finally without except. This is the end for this episode. If you find this video helpful, don't forget to like, share and subscribe for more Python programming content like this. See you in the next episode.